Hey guys, welcome back to Ox Tools. I'm Tom. So we're going to get started on this toe jack project here. I don't know, this is probably going to be at least 4 episodes, I think. Should be pretty interesting. First thing we're going to work on is this the main tube here. I've converted my chicken sketch into a real dimension drawing now, so I'm kind of ready to go on that. And James Kilroy gave me some dimensions for the actual the toe part, so I don't have that material sitting here, but I have all the other pieces. So let's go over to the mill and let's get cracking on that tube. There's a bit of work to do on that tube, so let's work on that. All right, so what we got here is this is a 4-inch tube. All right. So what's that? That's 50. That's a 100 millimeter tube, right? Is that right? Yeah. Brain's not on right now. So it's 100 millimeter square tube with about a 13 mil wall thickness, half inch wall thickness. And since my Johnson broke, I had to use my Portaband to cut this off. So it looks like a rat chewed this cut here, but we did get it separated. Now, unfortunately, I cut it a little bit too long. I thought I was going to make this all in one piece, and you'll see that in a little bit. So we got to take a little bit off of the length is the bottom line. So I probably got about that much to come off. So we're, instead of sawing it, we're just going to mill it off. And what I'm using here is, this is a fine pitch roughing end mill. And this is a high-speed tool that has a coating on it. And this is made by YG Tools. And it's one of my favorite, let's see if I get the tube here. Yeah, so it's made by YG. And there's a spec there. Oh, it's got hard lube on it, that's what it is. So it's 4-flute, regular, center cutting, fine, rougher, with hard lube. And these are made in Korea, and I've been using these for years. And what sold me on them originally was they gave you cobalt for high-speed price. So you got a, kind of a free upgrade. That's how they got people buying their tools. But their tools actually work really good. So and you'll see that in a sec, because we're going to bury that thing in there and we're going to take some off of that. The other thing is, obviously this isn't going to reach, so we're going to need to roll the tubing over. So this is something that comes up every once in a while when you have actually large tubes. It's a real problem, is, how do you get all those surfaces to be a single plane, right? And so we're going to show that too. So let me get that all set up, and we'll make our first cut, and then we'll go from there, okay? All right, so I think we're ready to go. So our first cut is going to be, we're going to reach, pretty much as far as this thing will reach. So this is a kind of a normal length end mill. So we're actually reaching past that wall thickness and catching some of this wall too, and you'll see why we need to do that in just a sec. So let me get the liquid love going here. And you can probably just faintly see, that's all the coolant you really need. So for this situation. So it's a 1/2-inch end mill. I'm running about 600 RPM, and that's so 13 millimeter. So I'll touch off, make sure the vise is tight. Touch off, and take a little bite. And now we're gonna dig it. We'll dig in a little bit. And remember, this is a high-speed tool, okay? And you can see this is cooperating pretty well here. So actually I'm going to go back across. I probably didn't need to do that, but it'll be alright. Alright, let's stop that. Turn this off. Okay. So we've taken a pass. So what we're going to do is we're going to set up our mill stop, and we're going to set it up below this wall thickness, and we're going to touch off here. And what that'll allow us to do is rotate this part around and keep working on it. And so we're gauging on the same end that we're cutting. So it's just a slightly different technique. So let me get that going, and then I'll show you guys that setup. Okay, so we got our stop kind of set height-wise. So I'm going to set it, fairly level. But I want to make sure I'm below this level here, and I'm just going to touch off here and then snug this up with it in contact with the part. Let's make sure that it's. Let me do that again. Make sure I got it. Make sure it's touching well. Sometimes it's hard to tighten it up and get it to be touching at the same time, but it looks okay now. Okay, so now what we do is we bring this up, let's come out, and basically we go down until we're pretty close to that, all right? And that's it, we don't go any deeper than that now, all right? So, the next cut, I just take this out, I roll this over like so, and now you can see that I'm, oops, you know what? Oh no, I zeroed it, good boy. I didn't remember if I zeroed the DRO, but I'm pretty sure I did, so let's see. Oh, you know what? I don't think I did. All right, well, anyway, I was supposed to zero the DRO before I moved the, moved the tool, but it's not going to matter because we got a lot to take off. So, but anyway, so now we're gauging on the same surface that we're cutting, so as we roll this around, the cut, when I zero the cut out, it ends up in the same place, so that's the whole idea. And you can see the blends there, they're pretty good, so. All right, last side. Okay. Alright, pretty good. So, it gets something welded on there anyway, so we don't really care that it's got the roughing end mill finish on it, so. Alright, so we get the length carved away, and you can see the chips that fine pitch rougher makes. They're really easy to deal with. You can just vacuum them up. Now the next step here is I want to take one side of this off down to a 1/2 inch. I have these big corner radii here, and what I need to end up with is one side of this at 4 inches wide and with a sharp corner. So that'll be the side that the toe actually mounts to. So what I'm going to do is I'm just going to cut through this corner here and knock this top section off. But before I do that, what I want to do is, I'm a little bit worried about, you know, what happens when I actually break through the tube. Is it going to close down? Is it going to open up? You know, I always worry about these kinds of things because I've been hosed by them in the past. So what I'm going to do is I'm going to put a little jack on the inside here to help. Let's see if I can do this without looking like a complete klutzoid here. I'm going to run this out here like this, and I'm just going to crank this and secure that, and I'm going to put one at each end. Maybe should have used the swivel ends. All right, so we'll put a little pressure on that, and I'll put one in at the other end, and that way, you know, if it decides to go bozo on me and close up, it doesn't pop out of the vise or do something obnoxious like that. So, you know, it's a chicken jack is what it is. So let me stick this other one in, and then we'll get started plowing that side off of there. All right, so we're motoring through the side of that there, and then we'll step over a little bit more to cut through that. So it's, you know, it's a couple passes to do it, and I'll do the opposite side. So you can hear how quiet this is. These fine pitch roughers are really good for lower horsepower machines. They don't fling blazing hot chips all over the shop, and they're cobalt, so they last quite a while. You know, in aluminum, these things really last a long time. So anyway, nice tool. So that's the feed rate that we're using approximately. So 1,000, 2,000, 3,000, 4,000. So it's, you know, roughly 4 seconds, 200 thousandths in 4 seconds. So you can calculate the feed rate based on that. But that's respectable, and a half-inch cut in steel. So not too bad. Well, you remember how I said the jacks would keep it from doing something weird? Well, there was this little membrane that was left, and when the cutter was about here, it went bing, and it popped and made a big noise. Scared the weasel snot out of me, but nothing happened, so fortunately. So everything's behaving itself okay, and it's about to finish this cut here. So from here to here is a half-inch, which is the plate that I'll be replacing this with, but it'll come all the way out to this edge. So I'm going to lop this other side off, and then we'll get to work on the main plate that goes on the front of this. Well, this is probably a good place to do a little filming here. We're getting ready to drop this plate off here, and you can see there's some stress in that. I don't know if you can see that curve in that thing there, but it's got a pretty significant curve building up in it, and it's starting to vibrate a little bit. So this is probably an interesting place to film, and you can watch it drop off, hopefully, without any mishap. So I'm going to feed it by hand now. And you can see it vibrating. And it's vibrating pretty good now. Here. right. Mildly interesting, but nothing alarming. So there's a hunk we got out of there, and it's pretty badly bowed. Let's finish this off here. Okay. All right. Right. You guys can get an idea. Let me grab that other plate. Oh, it has a plate that's going to go on like this. So you see I get the full 4-inch sharp corner width there, and then I only have to make 2 welds here instead of building a box out of plates. That's the general idea. And this will have the keyhole slots in it, as you saw in my little chicken sketch, but correctly oriented. All right, so do a little deburring here and pull this little monkey out and get to work on the other plate. All right, boys. So we got this tube opened up, and I went ahead and prepped these pieces here. This is the plate that will have our oops, draw it right there, Mr. Wizard. Our keyhole slots in, okay, and then this is the top bit here, okay. So there's a series of holes, and then there's actually some pockets here that we're going to dig down and remove some material out of too. So this plate actually probably has the majority of the work in it. So let's go over in the mill and smack some holes. Well, we're using one of my favorite hole making tools, the Hugin Rotabroach. Oh, there it is. Get the little mushroom out of there, okay. I'll just show a couple of them. So, this is a 3/4 inch diameter, and this plate is a 1/2 inch thick, and we're running about right around 500 RPM. I actually, just out of curiosity, I went to the Hugin website and looked at their recommended cutting speed, and they recommend about 100 feet per minute cutting speed for these guys. So I said, well, let's try it. It seems a little fast to me because it's getting pretty hot. And you know, if you run them a little slower, they just last longer. And I'm such a cheapskate that you know, I like to keep them for years between sharpenings. So anyway, so we got our big holes in there, and now we're going to do we'll do our slotting here, and then our pocketing in a little bit. Beep. All right, that's the capture pin there. Beep. Okay. All right, a couple more to do. All right, so we're going to cut this last pocket. I've cut the other two already, but I figured you guys would want to see this, at least one of them. And you can see the pocket here. Now this pocket engages a key on the back of the toe and really takes the load of the that's on the toe and the jack. So these are pretty important pockets. So we're going to cut a pocket in this area here. So the first thing I'm going to do is I'm just going to define the edge of the pocket, I'm on one corner of it right now, so I'm just going to basically make a rectangle that is the size of the pocket. But I'm only going to cut into the surface a little bit in case I pull a bozo move. Let's double check I'm on the right numbers here. So I'm just going to cut in a little bit. 850, 840. Okay, so that's the next corner. Then I'll come over to this side. Okay, there's the other corner. And I'll come down to 725. Alright, and then we're back to the start. So now what this does for me, and I'll stop the spindle here in a sec. What this does for me is it just gives me, and you could also lay this out with a scribe too, but it just gives me a visual witness line to work to so that I don't have to drive to the numbers every single time, right? So now what I can do is go off the part a little bit and then sink this down in there. In fact, I'm just going to go in about 1/8 of an inch, okay? Get a little juice going here. Okay, and now I'm just going to plow this material out of here, and I'm off of the line, so to speak. Okay, and I'll come up and visually get close, but not land on it. Basically just a witness line. This is a common technique, but very useful and allows you to go pretty fast. And now we'll carve away this little island. Okay. Alright, so that's partial depth. We'll go out of our little hole there. Alright, now we're going to go down to pretty close to the finished depth. Leave about 10 thousandths. Alright. And go for it. And we'll do the same thing. Okay, so now we're on depth, and we're gonna do the finish pass here. So I got to pay attention to the numbers. So it'll clean up the wall and the floor at the same time. Okay. One Pocketti. Let's see. All right. There it is. That's 200 thousandths deep. And like I said, the edge, there's a keyway that engages with that lower edge there. So I think this plate's done.